Good afternoon, everyone. My name is Chris Cole. I'm Leader of Sensing Scientists for at the BLM National Operations Center. And we are going to discuss the use of unmanned aircraft systems for resource management and fine-scale monitoring. So a little intro here. The BLM is actually a leader in the use of UAS technologies for managing resources on public lands. I'm not sure if many of you knew that, but it's true. And we're producing fine-scale geospatial information over multiple study sites as part of that using UAS. And we're also actively pursuing the use of UAS to derive select AIM terrestrial plot level indicators, including cover type and percentage cover. And these UAS derived indicators, terrestrial indicators, are really designed to supplement, enhance, and extend AIM field collection efforts. They're not deemed as a replacement for that. There's no substitute for field collection. So, we're going to provide an overview of UAS applications, UAS technologies, and their relevance for resource management. I'm going to describe some of the geospatial products you can derive using UAS. I'm going to highlight some of these selected resource management applications and completed projects which involve the BLM and our collaborators. Then I'm going to conclude with a discussion of a photogrammetric point cloud classification study which has a relevance for fine-scale monitoring using UAS. So, for those of you who don't know what a UAS is, defined as an aircraft system with no pilot aboard. That's a bit of a misnomer. They're not unmanned. They require the human element, human operation and control, albeit done remotely. Okay. You've heard a lot of talk about drones in the news, predators. Yeah, we don't have those. We fly smaller, lightweight, flexible systems that are unarmed, less than 55 pounds. Should have thrown that in there. So a lot of information to distill in this slide, but really the reason we're using UAS technology is because they provide that fine-scale, high-quality, cost-effective geospatial information, scientific products for resource monitoring. They're more cost-effective, it's a flexible collection system, and also when you consider safety concerns, aviation safety concerns, UAS systems have real benefit in that regard. So the Department of the Interior, which of course includes BLM and USGS, who actually is a close UAS mission partner, I must say. We fly currently 3 different UAS platforms. 2 of these you see here, the Raven and the T-Hawk. The Raven is battery powered. The T-Hawk is gasoline powered. Again, small, flexible, less than 55 pounds. SuperBat, MOB SuperBat is our newest UAS system, and we're very excited about this. It's slightly larger than the Raven. It is gasoline powered. It has additional imaging capabilities, including the ability to collect multispectral information, so it's sensitive to the near-infrared range of the electromagnetic spectrum, which is very useful for vegetation. So we're very excited about this for various terrestrial monitoring applications. I can go into too much detail on UAS camera systems, imaging systems, but they include full motion video, thermal infrared, host of digital cameras, including true color and, as I mentioned, multispectral imagery sensitive to the near-infrared range. So one of the great things about UAS, they fly at such low altitudes, much lower than traditional remote sensing platforms. Obviously, you're able to derive very, very fine-scale geospatial information using UAS. Some of those products include full motion video, but more importantly, I think, for our purposes, high-quality ortho images, digital elevation models, 3-dimensional point cloud data. Now that is similar LiDAR-like, if you will, similar to the data you may find using LiDAR. But this is differentiated from LiDAR in that you can actually capture RGB point cloud values, so color values, which gives you more contextual information to classify data and cover type. And it's also much more cost-effective compared to LiDAR, generally speaking, reflected over smaller areas. Scores of UAS applications. I cannot talk about all of them, but obviously germane to this discussion, rangeline health, and particularly to the symposium, AIM field data collection. So what we're going to do is talk a little bit about some of these applications and some of these projects we've completed involving BLM and collaborators. Have to acknowledge first the work of Booth and Cox. Many of you probably are already familiar with this, still bears repeating, I think. They use ultra high resolution imagery collected both by air and ground. These are manned UAS-based systems to measure cover at very fine spatial scales. And in doing so, they demonstrated the use of ultra-high-resolution imagery to assess rangeland cover and also to measure terrestrial indicators such as bare ground. I have to acknowledge some work of some people in this room, actually, individuals from the ARS Jornada Range in southern New Mexico. This effort used a UAS system of BAT, actually, to produce high-resolution DEM information over a portion of the Jornada. It was collected by UAS. It was processed using special photogrammetric software, structured motion photogrammetric software. Produced a very fine-scale, very good quality digital elevation model, and this was comparable, in fact, to in-situ elevation measurements obtained at the site. And the real power of this type of information, you can then model rangeland topography at a very fine spatial scale. You can measure things such as erosion at a fine spatial scale using repeat pass imaging. So in other words, you can monitor a given area over time and get these estimates at a very fine scale. I kind of quickly want to throw this out there because it's a cool project. This was a UAS effort to provide photogrammetric documentation of mammoth tracks also in southern New Mexico at White Sands. And one of the beauties, again, of remote sensing and UAS-based imaging, you can observe these tracks and monitor them over time without actually adversely affecting them. These are fragile tracks, so you can monitor disturbances, erosion, whatever that may actually occur at the site over time, getting repeat imaging and exploiting those geospatial products. So looking at wildlife populations, this effort efficiently mapped thousands of sandhill cranes and wildlife refuge in Colorado, and this was actually a joint Fish and Wildlife Service, USGS, and BLM study. One of the tremendous things about this was a tremendous cost savings when you compare the UAS-based methods to traditional fixed-wing surveys. And again, the aviation safety component looms large here. This is a safe method to measure these population counts. Another kind of collaborative effort involving BLM and Mason County Sheriff's Department. This was actually a multi-project effort, but for the purposes of this slide, we're going to talk about the volumetric change estimation over a gravel pit using multi-date images collected by a UAS. And again, a very sizable cost savings when you compare the UAS-based technologies to traditional aerial mapping systems. So that's, I think, something to strongly consider in the benefits of UAS. So kind of shifting gears here, remote sensing as field data. We can use UAS imagery to essentially replicate AIM-based, field-based collection measurements, cover estimates, okay? And so how do we do that? Well, again, we have very fine-scale spatial information, high-resolution imagery, which is useful for discriminating cover types. You also collect this in stereo, which allows you qualitative analysis of cover types, but also quantitative estimation of cover height, which is very powerful. And again, this is something you can do. We can implement this in very difficult to reach areas. You may not be able to field sample in every area because it's a remote location. It may not be safe. So something to consider. This is very powerful data, no doubt, but again, we want to emphasize this is not a substitute for field data. This is a complement or kind of an extension of it, I think. So this dovetails nicely with the very good discussion by Scott and Tina earlier about the NPRA. This is a photogrammetric point cloud study, which was done using obviously point clouds from actually a manned system. This is a helicopter-based system. I collected a digital camera from a helicopter, but it was collected over 2 study sites at the NPRA. Okay, and these were AIM plots, as Scott and Tina showed before. And this effort mapped 6 different cover types from point clouds, data, or non-UAS based point cloud data for both sites, including bare soil, graminoids, shrubs, forbs, herbaceous, rocks, and litter. And we're going to look at that now. And so, yes, this was actually a non-UAS based study, but we have to kind of mention that the data, the results, the methods that we found employed in this study are very transferable to something you would do with UAS-based collection in terms of the imagery, in terms of the altitude. So very, very transferable to an AIM selection methodology. So here are the two study sites again. They are both on the southern end of the NPRA. Site 1, typified by more bare soil and rock cover. Site 2, obviously more vegetated, more shrub cover. Okay. Kind of a quick rundown on data and methods. So hundreds of images were acquired for each of those sites, those AIM plots, using a helicopter-mounted digital camera. We processed that imagery using two software, PhotoScan and Cloud Compare, and then they were classified using a support vector machine learning algorithm, which basically classifies data based on decision planes in a multidimensional space. So you can classify a lot of different cover types using this classification methodology. So here are the data, the imagery collected for those two AIM plots from, again, that helicopter-mounted digital camera. And these are the actual classified cover estimates from the imagery, okay, for those AIM plots. Again, classified in 6 different classes, from bare soil to litter. Those black dots, hopefully you can see, they represent actual AIM line point intercept points. So this is basically just a comparison of the results we obtained classifying the imagery, the image point clouds and derivatives from the helicopter-based study versus the actual observed AIM plot level summaries. Okay, and I think overall we found good results. I think there are a couple areas I think we need to kind of further understand and potentially resolve. And for site 1, that would include the disparity in the mapping between bare soil and litter. And for site 2, the disparities between the AIM and the classified point cloud cover estimates for bare soil and for shrub. Same information, just visualized in bar format if you prefer that. How are we doing on time? I could do a rap if you guys want. You could break dance. Okay, so yeah, in conclusion, UAS technologies are being used by the BLM for many resource management applications over multiple study sites. And these UAS-based indicator products are really designed, again, to supplement, enhance, extend AIM field data collection efforts, not to replace them. And the results and methods which I described in the photogrammetric point cloud study could very, I think, easily be obtained, adapted to a UAS-based technology, UAS collection methodologies. And if you have any questions, please contact me or the other individuals listed. We're all at the National Operations Center. Lance and Brian are more the UAS gurus. And that's it. I'll be happy to entertain questions.
So for those of the other, how do we request the UAS for the
could you be, are you,
formal process?
I thought you were aiming for I'm curious about this. Yeah. So yeah, actually, and that's one of the things I cut out of the presentation. There's a huge workflow, but basically you send us an email, you request something. You or whoever the entity is that requests this sends us an email, phone call, whatever, and we talk about it.
So is there any kind of program where you're going to be predicting the same area, like flying the same area for the next 10 years? Is there any program like that, like for plan for activity?
That's actually a really good question. So this is still, I think, in the state. I'm sorry? The question was, are we going to do some kind of consolidated, basically multi-year revisit of a given study site or study sites, correct? Good question. I think this program is still kind of in a state of infancy, and it's been based largely on the requesters and what their mission needs are. That being said, I'm new to the NOC, so I've been here about 3 months. That's one of my visions to do exactly that. I would like to have a kind of a codified, consolidated plan where we do actually revisit certain study sites based on a given effort.
Will this information be available to the public?
web-based platform?
Question is, will the information be available to the public? Yes, that is the point of all this. This is not commercial restricted imagery. This is, and someone shoot me if I'm wrong, but this is designed to be given to the public, made available to the public, the data and product. Now, this stuff is not for the faint of heart. It's large amounts of data in terms of if you want the imagery, the products, or the analysis. But yes, this is going to be made available to the public.
Any timeframes for that?
So again, this is kind of an ongoing effort, but there are other kind of historical projects which the data are, has been made available, could be made available to others. What we can talk about.
Chris, I assume that you so we want to look at the whole landscape. Surveying that part.
The question regards line of sight and being able to kind of broader scale synoptic observation of the landscape, correct? That's a good question. Yes, we are under line of sight. We typically fly under 400 feet AGL line of sight. We can fly higher, and we have in several instances, up to 1,200 feet. We could fly theoretically higher, but and we do operate under line of sight. So what I would say is UAS is, if you look at our remote sensing toolkit, our arsenal, it's one of those toolkits in the arsenal. We've got fine scale information, but you also cannot kind of relegate the synoptic and broad scale remote sensing observation systems to kind of obscurity. You need to integrate those into that plan. So I would say this isn't the sole answer for landscape-based analysis. It can provide scaling studies, and it can provide more informed information on those fine scale areas, but we're still going to use moderate, broad scale imagery for landscape studies.
So you would use
Absolutely. Yeah, I'm not trying, we're not trying to privilege any remote sensing, whatever does the job, but typically what does the job are multiple systems working in concert. There's no silver bullet. So. Do we have, can I answer? Oh, yeah. Well, sorry, what was the question? Oh, so the pilots, that, that is a good question. I do not know. And I would contact Lance Brady for that one. Yeah. Okay, great.
Thanks, Chris.